And see, the colors are changing. So these are moving together. Nothing is disjointed. A LED does not just randomly go somewhere. Every one of these LEDs follows a route that is not disjointed. So I've been working on this dodecahedron, and I kind of wanted to show you what I was working on. So I'm going to run this code and kind of describe what's going on. My buddy, he's been designing this dodecahedron that you see here. And I feel so fortunate that he trusted me enough to take it home, you know, and this is his baby. But I learned a lot about dodecahedrons. What's interesting about a dodecahedron is that all the vertices have an odd number of edges connected to them. What that means is that these LEDs are wired together in series. That's how they're supposed to be. So how these RGB LEDs work, they have an internal microcontroller on them. You just send a pulse width modulated signal, pretty much Morse code, on off with short and long dashes, to these pixels. Each of them will take the first data set, which contains red, green, blue values, and then it just sends the rest. So it doesn't send the one that it snagged itself. And so it's pretty ingenious. It's a way that you can actually have all these LEDs. It's easy to address them, you know, 0 through whatever number. But a problem that you face is that when you're wiring up a dodecahedron, you can't put them in series. You're going to have jumps. And not only are you going to have jumps, you're going to have a minimum of 10 jumps. And that is because there is no Euler line on a dodecahedron. So what you see here is a two-dimensional projection of a dodecahedron.
Welcome to my channel.
And the two-dimensional projection of the dodecahedron allows me to visualize it. It's almost as if you're seeing it from this view. Now this, of course, you're seeing it two-dimensionally flattened from 3D, but this one that I have here is done so in a little bit more systematic way, and it's spread out. I don't have these overlapping. I don't have this overlapping, you know, the line behind it. Each of them is wired sequentially. So it starts off with 1, and then it hits the vertice, right? One vertice is down there, but when it hits the vertice, this vertice PCB sends the data signal through down 2 and back around. Back to the vertice, and then to 3. So, of course, there's 10 of these jumps that it's making, which is half of the vertice. So all the vertices actually have an in-out and then kind of a loop, except for the last one. It's kind of fun stuff. So in math, it's interesting what Euler lines were. I didn't know much about Euler lines beforehand, and now I know a little bit about them. When I was helping my buddy, he didn't ask for much help. I always lend more help than people ask me to, because I find usually if I find something enjoyable about the project, I want to wrap my brain around it. I made these diagrams just to kind of help myself
wrap my brain around it.
So I started off by, you know, naming them. These are the PCBs that are designed. This is an old version of them. I just tried to make them kind of look cool. This is the a paper copy that I made. And here's some of the earlier drawings that I had. What I found about this is I wanted, when I'm drawing pixels, I don't want it to jump anywhere, right? So the wires, you have to jump from one section to another or loop them. But I wanted this nice continuous flow. And you can go through these and sequentially, so you go down 1, go down 1, go down 2, and then back, and then to 3. You can do this, and it will draw an interesting pattern. But I didn't want that to be the only pattern, so I found this one, which consists of some command. It looks kind of funny, but this command is right, left, left, right, left, 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 back, left, left. So it starts on number 1, and it ends on this number 9 here. If you repeat this pattern, it will go across the whole dodecahedron, and it will hit all of the edges in both directions, and just till it hits all the vertices. The very outside ones only get hit once, which is interesting. Another interesting thing about this pattern is it's 60 long, so it has to go through 60 iterations. A lot of this probably has names. There's names for it probably in mathematics, but I am not a math major. And in fact, I'm just an enthusiast, so I just try to do my best. But I found this pattern, I found this way of actually addressing the LEDs that I thought was kind of cool, and I wanted to write a library for it. This is my library. It's not done yet, it's just functional. But what I find interesting is if each of the vertices I just labeled with the number, like you see on this diagram, but the number is specific to the direction that the LED is pointing. So this 15 is connected to a 2 and a 14 here, but the 15 on this one is a positive number because it's going out from the vertice, as where the 15 on this one, where it's 15, 17, 16, the 15 is coming in, so that's a negative 15. Now with that information, I'm able to iterate or recursively draw patterns on this dodecahedron pretty easily. So if I know what edge, 15, since it's positive, not only do I know what edge it's on, I also know what direction it is in. So I do some simple math by just either flipping the 15, I can find what vertice it's connected to. So if I look for 15 in this array of vertices, I just look for the other 15, which is here, and of course it's negative. So I know that 15 is connected to 17 and 16, and negative 15 is connected to 2 and 14. So if we look on the diagram, this is the case. A 15 here is connected to this group and this group. I just give it the values, and I can tell what the other edges are connected to it. So my pattern, since I have to specify right or left, so when there's a fork in the road, you have 3 options, right? You can go right, you can go left, or you can go backwards. So those are our options. First, it's going to draw... Oh yeah, so what I did is I created these pixels here. So I created 15 of them, and they're all using my sequence, right, left, left, right, left, 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 back, left, left. They have random colors associated with them. They're only 1 long. And my program will just move them 1 in the direction that they're headed. So they have a address when it comes to what edge they're on, and they also have a address which pixel they are. But yeah, negative I plus 1. Okay, so this is the pattern. So what's interesting is that you'll notice in a little bit there's going to be a void here.
Welcome to my channel.
Yeah, there it is. The void appears. I don't know if that's an error in my code, but I don't think that it is. But a certain void exists, and yeah, I find that fascinating. They all go to a certain area, when technically this pattern is repeated across the dodecahedron evenly. So it's interesting that it's a non-even distribution. And dodecahedrons are quite complex. Trying to hold this code in my head was difficult, and that's why I like the challenge so much. So the whole code just relies on what I'm doing here is running something called move. So I give it the vertices with those names of the edges. I give it the neopixel value, and it goes and it just kind of parses the pixel, the global pixel data, and that's where I define it. It has an edge and direction. They're both the same integer. And it has a pixel value, so 0 through 9, because there are 10 LEDs per edge. Starting point, it also has a speed and a length. I haven't utilized those yet. It has a sequence, which is what it's going to do when it hits a vertice. It has a color value, which right now is random, and then it has a time to live. And it pulls out first those values. And when I actually made the vertices here, I have them all counterclockwise in order. Counterclockwise based off of this projection. There's probably a math terminology I should know here, but I don't know it. But if you actually list them counterclockwise and not just randomly, it does matter what order that they're in. But there was still only 1 LED on this branch for some reason. And see, the colors are changing. So these are moving together. Nothing is disjointed. A LED does not just randomly go somewhere. Every one of these LEDs follows a route that is not disjointed. It's easy to just make something, bounce back and forth on one edge, but this is not doing that. This has 60 separate pixels, all starting, and they're following a pattern around. They're hitting every edge on the dodecahedron. So it looks simple, but it is not simple. And I was very hard pressed to find some kind of line. And I don't know what type of line this is called, but it's a line that you can repeat a pattern. The shortest line that you can repeat a pattern on a three-dimensional object. This is a platonic solid, of course, the dodecahedron, but this has been in the works for a long time. Harry's been designing this, and I came up with all these diagrams just to kind of help my mind wrap around it. And I wanted to create a virtual dodecahedron so I could run my code on it, but I started coding it in Blender, and I was just like, you know what? It is just so hard to set up a virtual dodecahedron because you actually have to plot it in XYZ and do some other calculations. And it was just really, really difficult. And it's actually so awesome that Harry let me see this and code on it for a week. So that way I could finally realize this pattern. And I've had this pattern, right, left, left, right, left, 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 back, left, left. I've had this pattern for about 4 or 5 months. I sent an email to Harry when I found this pattern, this line. And I don't know what line it's called, but I'm going to name it the turf line since I have no clue. But I'm curious what mathematicians, because I'm not familiar too much with how, you would write this in just an equation in math, like Sigma notation. But I find it a very fascinating thing to program on, and I think other people are gonna like this too. It just looks super awesome, and this is only version 2, so he's working on version 3 that's even better. I think I would buy this, and I said that this is worth it. And he soldered this by hand. All the LEDs, no, these LEDs he actually had, I think, made, but he soldered all the vertices and the edge pieces because each of these consists of, yeah, so that has the PCB right down here is where the LEDs are on, and you can see the feet of the LEDs. This one is the rib piece that fits into these holes, and then up here are the different vertices. And this was my kind of silly screen print that I kind of designed to go on the actual vertices and PCBs themselves. I just felt super honored that Harry let me borrow this for a while, and I'm definitely gonna buy one when he actually releases them. I like this version, and his next version is probably better, but this version looks cool, and he's gonna put mirrors on these. And you can buy infinity dodecahedrons, but this one I think is awesome because I think he's gonna make it into a kit. I'm not sure. But you'll get to solder the pieces, or he was gonna have it solderless, but I don't think he is going to keep that design, because I told him that I think people are going to like to solder the pieces together if they're into electronics. And I mean, that's mostly who you're selling this toward. And if they want a final completed version, well, then they could just order a completed one too. But these are pieces of art, in my opinion. Not just the PCB was designed custom, but even the code is. So if you're into coding, I challenge you to write code for a dodecahedron. Find something that's not just jointed, because the random walk is okay that you can do on this. Just, light up the LEDs 0 through 300, 0 through 299. But it's much better if you try to make something elegant. To me, it's like poetry. I'm a super nerd, and I like that about myself because I'm also a musician. I'm also a poet. But this is like poetry to me for programming, because there is something I find elegant about this pattern. It's really hard for me to tell verbally what I like about this pattern, but if I can show the pattern, then I just don't have to explain it, I guess. Maybe I'll still be that stupid guy at the party like, no, you don't understand. When the vertices hit, it's not just, yeah, I'm totally going to be that guy. But until then, at least I showed you guys. Yeah, so I've had fun with this. I want to make this a little bit faster. I'm going to spend some time on this tonight. But yeah, that's it. That's all I wanted to live stream. Live stream is also kind of nice because I can pull up and download the video, and then I can edit it for later. But I mostly just wanted to share with you guys what I've been nerding out on, probably why I haven't been streaming very often. And also, I'm trying to quit smoking, so I do apologize if I vape, because it's going to be much healthier for me if I switch to vaping for the short term. Hopefully, then even quit vaping. But you guys, hopefully everyone is having a good day. Hopefully you find something that you enjoy as much as I enjoy writing a dodecahedron. I just wanted to share my joy with you guys, because one of my good friends always says that if you share your joy, you double it, and if you share your sorrow, you half it. And with that, I just hope that we can all make a positive difference, and I just challenge anyone to continue to do things that you love, that you enjoy, to challenge yourself in a positive way. Until next time, have a great day, guys.